Okay, so the next thing we need to do, or the thing we need to do for here, for example, one is we're trying to prove that this is a dilation. Okay, and if so, we need to identify what that dilation was, which means identifying the scale factor, which we'll call K. All right, so first thing we want to do is verify a few things. Okay, one, we need to understand what we started with and where the center of dilation is and all that kind of stuff. So, center of dilation is the origin. I know this picture is relatively small. You'll have to work with me here. And then we have the image, the pre-image, which is DEF, and then we have the image, which is after the dilation, which is D prime, E prime, and F prime. Okay, so the first thing I did is wanted to kind of mark those dots out so that we kind of get an idea of what's happened here. All right, so the first thing we want to do is we want to verify the shape, orientation, and the angles have all been preserved. They're all the same. In other words, we want to make sure you have the same angles. Now, they kind of told us they did, right, which is kind of nice of them. They showed the double lines here to show that those are congruent angles. Here, you have the double lines to show that we maintain congruence, which was nice of them to do. But also, oftentimes, you can just kind of look and see. And also when you check for the lines are parallel, that'll maintain congruent angles. So that's kind of easy. So you really just need to look and make sure basically that it's the same shape that it was before. It's not, points aren't off, the angles haven't changed. It's a little, something doesn't look different. So angle D and D prime have the same angle. E and E prime have the same angle measurement. And then F and F prime have the same angle measurement. So that's the first thing we need to check. Next thing you need to check is that everything's parallel. That's relatively easy here. What you would want to do is kind of count your slopes. So D to E prime, D prime to E prime would be 1, 2, 3, 4, 5, 6, 7, 8 down 2. So that would be negative 1/4, rise over run. And then this one would be 1, 2, 3, 4 down 1, so negative 1/4 for DE. So those have the same slope. The vertical lines, obviously E prime and F prime, and then E and F. Those have to have the same slope because they're both vertical. And the last one, we have DF and D prime F prime. So that's DF is down 1, 2, 3, 4, 5 over 1, 2, 3, 4. I'm sorry, down 1, 2, 3, 4 over 1, 2, 3, 4. So slope of negative 1. And then D prime F prime 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3, 4, 5, 6, 7, 8. So the slopes are the same. Okay. Now, if the slopes of the corresponding sides are parallel, right, corresponding being DE and D prime E prime, or DF and D prime F prime, right, those are corresponding. It's the matching sides on each of the triangles. All right, because those are parallel, we've satisfied that. That has to be true if it's scale factor. The third thing we want to do is we want to verify that the distances have changed by a common scale factor. So, in other words, how did I get from D, right, from the center to D? Like, how far away is that? So that point was negative 2, 2. And my new point is negative 4, 4. So if my original point was negative 2, 2, and my new point is negative 4, 4, then what did I multiply by to make that happen, right? What factor would I multiply negative 2 and positive 2 by to get negative 4 and 4? And I hope y'all will see it's pretty easy, is this. We're multiplying by 2. So that gives us negative 4 and 4. Now that should work for all of the original points. So let's look at E. So if we did a dilation of a factor of 2 on 2, 1, then we should end up with 4, 2. And if we look over here, that is exactly where E prime is at. And then if we do the same thing, dilation of 2 on 2, negative 2, we should get 4, negative 4, okay? Which we do, right? So that shows that we are multiplying by the same scale factor of 2 each time. You can also show that by dividing. That's another way to do it. But if it's graphed, it's almost easier a lot of times just to see if you can kind of figure out one of them and then go from there. The last thing I want to make sure is that each point should be collinear with its prime point. What I mean by that is this. If you draw a line through E from the center, it should also go through E prime. Okay, same thing here. If I draw a line through F, I should go through F prime, and I should draw a line through D and D prime. Those are collinear, meaning that the original pre-image point and the image point are on the same linear function, same line. Okay, and once you prove all of those things, that does indeed show you that this is a dilation. Okay, so we'll stop it there.